Hello everyone, it's Professor Stevens back again to do example number 3 from section 1.8, Solving an Absolute Value Inequality, case 3. What is case 3? Well, let's just take a trip back in case you didn't see the previous videos recently. In the first one, when I introduced absolute value equations and inequalities, I went over these 3 cases in which case 1 is an equal sign when you could have 1 or 2 just dot answers. Case 3, where you can have a distance from 0 that is less than a certain amount. So you go to your endpoints and you would be trying to get closer to 0 rather than farther. And then the case where you could have a distance from 0 that is greater than a certain value. So you can see here, starting at k and moving up would be a greater distance away from 0, a greater distance than k. Or starting at negative k and moving down would be a greater distance than a greater distance than k. So example number 3, we get to work that out here. And the first thing we want to do is isolate the absolute value expression, which I will do now. So I have 5 minus 8x absolute value, and I'm subtracting 6 from each side to get 8. Now I want to take the inner part of my absolute value expression, and I'm going to tell you what to do with it, but first I'm going to explain something about it. And so that I can refer to it in a more simplistic way, I'm going to name this part of it f. And then I'm going to show you on the number line that if I'm here at 0 and there's some value f, perhaps over here, then its distance away from 0, according to this, has to be either equal or greater than 8 units, which means that 8 could be the value of f, or 9, or 10, and so on. Those would all be values of f, which would have a larger distance away from 0, a larger distance than 8. So that's why we would be moving outward away from the center, away from 0, from that point. On the other hand, I could have an f value that's down here somewhere. We'll call it negative f. And that value has to be 8 units or more away from 0. So this could be negative 8, or negative 9, or negative 10, and so on, moving down the number line away from 0. All right, so this number line represents the expression 5 minus 8x, or what I have named f. All right, now that I understand that much of it, though, I'm going to pull out that expression outside of the absolute value sign, and I see that this part can be less than negative f, so I'll write less than or equal to negative 8, right? Negative 8. Or that same expression can be greater than positive 8, greater than or equal to positive 8. So that's how you want to set it up. All right, so if you're trying to remember a procedure rather than really understanding the reason behind it, you could say it like this. You could say take out whatever's in the middle of the absolute value symbols and set it, let me see. You want to set it greater than or equal to 8, and then less than or equal to negative 8. All right, so you always got to start on this side of it with the positive 8. So you're using the same symbol that you originally had here, and you're not changing the sign of the the value on the other side. And then you're going to keep the direction the same, but put it on the other side of the expression and change the sign. Now, it works out, like you can use this setup, which I did on example number 2, but I should caution you that it is not really numerically correct, because it gives the impression that F is somewhere in between here and here. You know, when you look at it visually, it looks like that kind of, which is, it's tricky. I'm going to keep them separate just for clarity. Since I already did example 2 where I used the sandwich method, I'm going to use them separately here. All right, so I'll go ahead and do the inverse operations to isolate x on each one of my inequalities here. So first I'll have negative 8x is less than or equal to negative 8 minus 5, so that'll be negative 13. Then I'm going to be dividing by a negative, so I know I need to turn my symbol around, and then I'm going to have x equals negative 13 over negative 8, which results in positive 13 over 8 as one of my boundaries. Now I will do the other one. I have the same inverse operations to perform, so I will have negative 8x greater than or equal to 8 minus 5, which is positive 3. Then dividing by a negative, I will have to reverse my inequality symbol, and I will have x is equal to negative 3 over 8 as my other boundary. All right, so now I'm not going to put those on this number line at all. I'm going to make a new number line, because that number line represents the quantity 5 minus 8x, or f as I named it earlier. So I'm going to start a new number line down here for x, and I'm going to put the negative 3/8 over here and the positive 13/8 over here. And let's see. Now I will say, let me use light blue. I'm going to use a closed circle on each of those, since there is equivalence here. And I will have an x value that is greater than 13 over 8. So I'll be going higher than 13 over 8, and I can include 13 over 8, or 13/8. Right? And from negative 3/8, I will be looking for an x value that is less than that. So I will be moving down in the negative direction. And finally, I'll put this into interval notation for my final answer. So my solution set is from negative infinity to negative 3/8. I do want to include negative 3/8. Then I have a gap. So I'm going to union that first interval with the second interval, starting at 13/8 and including it, and going towards positive infinity. So that's it. That's how you answer that one. Let me stop here and start a new video.